Hi, class. This is basically your exam review because we have exam 3 coming up. Exam 3 is just like exercise 4 on page 123, where you can use all of the rules of implication, all of the rules of replacement, conditional proof, indirect proof. Except the exam will go a little farther than that. I will just state right now, you can't get full credit if you don't use conditional proof or indirect proof, because part of your job is to show understanding of those. Having said that, today we're just going to practice. I'm going to do several of the proofs for you on page 123 in exercise 4, and use this practice to the best of the way it's going to be helpful. So let's say you're pretty good and you can do some proofs, but you get stuck a little. You probably want to try practice as hard as you can, and then watch the rest of this video. However, if you're a little more at sea and you have trouble starting, it might be helpful to watch this video before you tackle more proofs. But again, the key is to practice enough until you feel comfortable, and you have the resources for that, because you don't actually need new proofs. You could still, you have new rules for old proofs, so you could still do all the proofs in 3.2, except now you could use conditional and indirect proof to simplify them. And then also with the additional exercises handout, you're welcome to go back through those and do conditional and indirect proof as well. So just practice. More generally, though, remember that conditional and indirect proof are just each one extra rule. Conditional proof builds conditionals. Indirect proof you could actually do with anything, but it's best used with smaller, simpler statements, as we talked about last time. And you can actually complete any proof as an indirect proof by assuming the negation of the conclusion. But we'll start with one where you could actually be a little more creative on that if you want. So again, these are working some problems in on 123, and I like to start with some that are in the back, and just so you can see why they're doing what they're doing as I'm kind of talking my way through them. So that's what we'll try. So let's start with number 8. A or L or O, premise, L if and only if O. From that it follows O or A. So immediately there are a couple of things that jump to mind. One, remember, before you do any of the shortcut rules, you should do the stuff that doesn't require them, just in case you need it later. So the first thing I'm going to do, there's exactly one thing you could do with the triple bar, which is to change it to both or neither. And then, or you can change it to L is both sufficient and necessary for O, also using a quiv. And then if you want, you could even simp. I don't know if I'm going to need any of these things, but I'm just going to do them because I don't want to forget later and then maybe get stuck simply because I forgot to do it. And so that gives me L hooks O and O hooks L. So before I've even started that, now we normally just look at our conclusion. If I'm building a disjunction, there's a couple ways to do it. We can do an addition if we can get O by itself. That doesn't look easy. We could go do a constructive dilemma. That doesn't look easy. Or we can do an indirect proof, because remember, if we negate this, we get not O or A, which gives us not O and not A, and then we can use that. There's yet another way in the back of the book. Remember, not O or A means not O hooks A. We'll let autofocus catch up here. So any disjunction can become, because any disjunction can become a horseshoe and vice versa, that actually means we could do a conditional proof. Assume not O and it leads to A. However, so those are 4 different paths you could take. Each one will be successful if you do it right, by the way. But I'm just going to do my usual method. I look at my conclusion. Does it occur in its entirety anywhere in the premises? Yes, I have an O and an A in line 1. What type of statement is line 1? It's a disjunction. What do I need to break up a disjunction? Disjunctive syllogism. Oh, what would I need to do a disjunctive syllogism there? Well, if I get it in the right form, L or A or O using line 1 com, and then L or A or O, line 8 associativity, and L or O or A, line 9 com. Now, if I get not L, I could just simply do a disjunctive syllogism. And so that's another thing that you might consider. What would that look like, though? Well, if we're doing that, what would we assume here? We would assume L, because we're ultimately trying to prove not L. And so now I ask my question, would assuming L help me break down any of these further? One method I do sometimes, I'll put a check mark next to every premise I've kind of either manipulated or broken down already. So if I had an L, what would that let me break down? Well, it would let me break down premise 5, oh, that one's broken down, and get O. And then what? Could I get a contradiction out of it? And here we have to be careful. And the reason we're being careful is because I already mentioned, even though I already mentioned you could always do an incomplete proof by assuming the negation of the conclusion, you can't always do an incomplete indirect proof otherwise. So the reason for that is actually something we might have here. Suppose the truth value of L doesn't matter to the conclusion. That is, suppose it's consistent to say that L is true, going back to our truth table assigning method, if L is true, A and O are true, which means the conclusion is true. Sorry, if L is true, O is true, and which means A is true or false and it doesn't matter, the conclusion will be true. If L is false, O is false, and A is true, making the conclusion true. So notice, whether L is true or false actually doesn't affect the validity of this argument, which means the reason you're not seeing a lot to do with the assumption of L is simply because you still don't have enough information to derive your conclusion, even if you assume L here. So instead, let's do one of these methods. I'm just going to assume, so we'll do it the easy way. Again, I hope that wasn't too long a digression. I just wanted to talk through some of the possibilities. Not O or A, it's an assumption for indirect proof. which means not O and not A, by 11 De Morgans, which means simp, com, simp. Now I bet I could break down some stuff. Let's look at the premises I didn't break down. Can I break down premise 7 yet? No, I can't do modus ponens. However, I can break down 5. So then I go not L, using lines 5 and 15, modus tollens, and not and then what? Well, if I do modus tollens again, I get not O, which I already have. And that's why I like to put check marks next to the one I already broke down. Well, wait a minute. I can, for instance, get O or A using line 10, disjunctive syllogism. And now you might be tempted to continue and say, well, I could do a disjunctive syllogism with lines 17 and 13 and get A and not A. That's a contradiction. But look, we already have one. 17 is the opposite of what we assumed. And so we could conjoin O or A, or not O or A, and not O or not A, using conjunction of lines 17 and 11. And that's a contradiction. That's impossible, which means our initial assumption must be false, and so we can prove the opposite, O or A, using lines 11 through 18. Now, conditional proof. Now, is that the shortest way we could have done the proof? Absolutely not. Notice we don't ever use several of these lines. And then also we talked a bunch about alternative strategies. So let me say 2 things. 1, you are not graded for efficiency. If you can do the proof correctly in 30 lines, you still get full credit as if you did it in 5 correctly. 2, I'm sorry to talk about so many possibilities. I don't mean to barrage you with these things, but again, we have a redundant system. There are multiple ways to complete this proof, and I don't want you to get stuck thinking there's just one. And so I kind of try to talk it through in a way that maybe it hits more of the students in the class that did it different ways. Especially, notice I did it a completely different way than they did in the back, which is to assume not O, show that it leads to A, and then do an implication at the end. Let's do one that's a little simpler in the back. That's number 2, which is premise. If it is the case that A or B and C or D, then E. Therefore, A and D hooks E. Now, overall, you should be able to kind of see that this follows, because pick one. If either of these and either of these leads to A, then just picking this one and this one should be fine. But proving that might be a little harder. First of all, this is a nightmare involving distribution if you do it without indirect and conditional proof. However, we don't need to worry about that. Instead, we do the same as always. Now, there's a couple of ways we could do that. First of all, notice the conclusion is logically equivalent to A hooks D hooks E. Does that help? Maybe. It depends on how good you are on these things conceptually, because what we would end up doing is doing a conditional proof within a conditional proof, which we haven't done before. But that might be worth doing, especially if we can't see how to get from A and D to A or B and C or D, because remember, we can't do an addition to part of a line. So the most straightforward way is simply to, let's assume this and show it leads to E. What would that look like? 2. A and D, that's an assumption for a conditional proof, which gives us simp, com, simp. Why am I doing this? Because you can't add to part of a line. And then we could do our 2 additions, A or B. Line 3 addition. Why am I doing this? Because we have to get to E, which means we have to modus ponens. And then D or C, which is line 5 addition, which gives us C or D. Line 7 com, which gives us A or B and C or D, using lines 6 and 8 conjunction. And now we could do the modus ponens and just get to E using lines 1 and 9. Hence, we have proven beyond a shadow of a doubt that on the assumption of A and D, that does indeed lead to E, lines 2 through 10, conditional proof. So, that's a pretty straightforward conditional proof, hopefully. The rest is kind of just, that's what I mean. Even if it's not a short number of steps, it's pretty straightforward. We're talking, simp, com, simp, and simple additions and modus ponens, rather than a bunch of convoluted distributions and simplifications and things. However, let me show you the other way to do it, just because the book talked about these a little bit. There's also the fact that we could do a conditional proof within a conditional proof. You never need to do this, and so if you just don't get it, maybe that's okay. But be aware that you could do it. So, what if we were trying to go and get, well, let's say A, assume for conditional proof, what am I trying to show? Now I'm trying to show that D implies E. Well, I could do A or B pretty easily using line 2 addition, and you might say, now what? Well, now what am I trying to get to? I'm still trying to get to D hooks E, which means I'm trying to build a conditional. So if I really wanted to, I could actually just go D, assume for conditional proof, trying to show E, and that's pretty easy. D or C, line 4 addition, C or D. Line 5 com. And then conjunction of A or B. Notice these are pretty much the same steps. C or D. That's lines 3 and 6. Conjunction, which means I now have E with lines 1 and 7, which means I have shown beyond a shadow of a doubt, take it back to the first indent, that D leads to E, which means now I have shown beyond a shadow of a doubt, unindenting back to the normal here, that, this is 4 to 8 CP, that I could do a conditional proof within a conditional proof, because I just showed using lines 2 through 9 that the assumption of the assumption of A entails if D then E, and that is logically equivalent to my conclusion. All right. That one is, sorry, and I need to line this off as well. That one is just as good. So if you can do that, you're in really good shape in terms of understanding. But it's what just like I can use double negation twice in a proof, I could certainly use simp twice in a proof. I could use conditional twice in a proof. If I am building a conditional within a conditional, then I can just do that with a conditional proof within a conditional proof. There's no problems there as long as you're careful. All right, so those are two of the ones in the back of the book. Let's just do a couple more, and we'll try to do them a little faster and not get into the wonky side notes. Let's say I'm doing number 4. Premise, D. Premise, A hooks B. Premise, E hooks C. Premise, not A, hooks that D hooks E. And B or C hooks F. Conclusion, F. So, don't change your method. I look at my conclusion. Does it occur in its entirety anywhere in the premises? Yes. I would need, if I don't have other methods, I would need to do modus ponens with D or C on line 5. So I have a D there and I have a C there. So if I could put these together, maybe, well, I could certainly put them together in a few ways. As soon as you start mentally stretching, if you don't see the immediate steps, it's a good time to start asking whether a conditional or indirect proof would help. That is, would having the extra premise that you need as an assumption help break things down, is the usual question. So would having not F break things down? Yes. By the way, if you don't want to do an indirect proof, what you would actually do, you could use exportation here, and you could use hypothetical syllogism. So you basically get not A and D hooks C, and then you need to get the not A to drop out using the D. But anyway, let's say you don't want to go through all that, and you just say, well, you know, I could start breaking some stuff down. Oops. If I had not F as a premise, so let's call that our assumption for indirect proof. Why does that let us break things down? Right there, modus tollens. Gives me not D and not C using I must have copied this proof wrong because that's way too easy. Yes, that's B or C, not D or C. I'm like, wait a minute. Okay, so we have not B and not C. Sorry, I'm skipping a step. It's going to get really messy. Apologize. Let's just restart. So, let me make sure I recorded the rest of this correctly. Yes. Oh, that's a much trickier proof that way. Anyway, so it's not any trickier when we have indirect proofs. So now, I get not B or C using lines 5 and 6, modus tollens, and then, of course, I use De Morgan's, and then I simp com simp. Okay. And again, if you want, you could kind of check mark all of the lines you've broken up. Well, I haven't broken up 2 yet. Can I? Sure I can. I can now use lines 2 and 9 for a very straightforward modus tollens. Gives me not A. Can I break down line 3? Yep, sure can. Gives me another very straightforward modus tollens. Gives me not E with lines 3 and 11. Ooh, this is conditional. Breaks down with modus ponens or modus tollens. I can modus ponens pretty easily. Gives me D hooks E with lines 4 and 12 modus ponens. And I could break this one down. Notice I can do modus ponens or modus tollens there. And you might say, wait a minute, no, you shouldn't be able to do that. Yes, because there's a contradiction. If I use D in modus ponens, I get E, which is a contradiction with line 13. Or if I use E to modus tollens, then I could get not D to be a contradiction with line 1. Doesn't matter which. I feel like I have done too many modus tollens, so I'm just going to use 14 and 1. And then now I can conjoin E and not E, which are lines 15 and 13. Conjunction. This is impossible. Why are we trying to get what's impossible? To show that our initial assumption is false, and instead F must be true, using lines 6 through 16, indirect proof. So, are there other ways to do that problem? Absolutely. But that one's a pretty straightforward in terms of ease and of maneuvers. Notice you might say, wow, 17 lines, that's a lot. Like, yeah, but they're all modus ponens, modus tollens, and simplification. Because, again, once you've committed yourself to an indirect proof, you're just trying to break stuff down to its smallest components. And very little strategy is required. And so, pretty easy that way. All right. Let's do number 5. Not A hooks. It is the case that not A hooks. It is the case that B and B. B hooks. It is the case that A hooks C and not C. From that, not A if and only if B, if I copied the problem correctly. So this is one of those annoying cases where I mentioned that most textbooks have this rule called tautology, that A is logically equivalent to A or A, and A is logically equivalent to A and A, which means this really just says if not A, then B. And I don't know, it bothers me a little that I can't just switch those out and simplify things. Having said that, that's okay because this helps us work on strategies. As I mentioned, what I like to do with a triple bar is to just do 2 conditional proofs, as I mentioned in the last video. Show that not A leads to B, and show that B leads to not A. And if you do that, makes things pretty easy. So, let's assume for conditional proof, so maybe as a side note, remember this is equivalent to not A hooks B and B hooks not A. So, first conditional proof, I'll assume not A and show that it leads to B. So let's assume for conditional proof, and now I'm trying to prove B. That's pretty easy. For I can do modus ponens, gives me not A hooks B and B. And then I could do modus ponens again to get B and B. And then I can just be with a simp. I have proven beyond a shadow of a doubt that not A hooks B. 3 to 6 conditional proof. All right, now I'm halfway done. Now I need to show that B leads to not A. So I'm going to indent again. Let's assume B for a conditional proof. How does B help us? Well, does it help much up here? No, but I can certainly do a modus ponens. So if I do a modus ponens, I get A hooks C and not C. That's lines 2 and 8 modus ponens. And you say, wait a minute, C and not C, that's a contradiction. So line 9 should strike you as very funny. If A is true, then the world explodes. A entails a contradiction. And so you can do a couple of things here. You could do the long painful way, which is to do an implication and do distribution and do some funny things that'll lead to not A. So what you would actually do here, in case you're keeping track at home, I'm just going to write off on the side. You go not A or C and not C, which if we distribute that, not A or C and not A or not C, and then we turn this into if A then C, and we turn this into if A then not C. And now what do? We transpose and go not C hooks not A, which means A hooks not A, which means not A or not A. And you're like, dang it, why am I not allowed to use this rule? However, remember, if we're looking at stuff like this, the rule that our textbook has instead is excluded middle introduction. But the other thing we can do is if A entails a contradiction, then wait a minute, that's what we're supposed to be looking for indirect proof. So I can do an indirect proof within a conditional proof, no problem. So that's an assumption for an indirect proof, which automatically gives me a contradiction of C and not C, using lines 9 and 10 modus ponens, which means I've proven beyond a shadow of a doubt that A is false. And now I have shown beyond a shadow of a doubt that B hooks not A. Sorry, this is 12. This is 13. With lines 8 through 12, conditional proof. Why did we want that? So we could conjoin not A hooks B and B hooks not A, using lines 7 and 13, conjunction, which is logically equivalent to our conclusion. Go us. Okay, so this is another example of why it's really helpful to understand how you can do and should do assumptive proofs within assumptive proofs. So a conditional proof within an indirect proof, or an indirect proof within a conditional proof, just like the one they did on page 122 before. Because if you don't do that, yeah, you could probably still do the proof, but you're going to get into some messes. By the way, notice you didn't actually finish this here. You would then need to introduce A or not A and do something similar. But anyway, and then do a distribution and simplification. But the point is, this exam, you're going to have to show understanding of conditional proof and indirect proof. And so even if you can do a long, convoluted way without, you're not going to get full credit anyway. And so just really pay attention and remember, these rules are like every other rule. Use it when it's helpful. Toss it away when it's not. In this case, well, I knew it was helpful for a conditional proof, but then I also noticed, well, I still need to get not A, and it's very intuitively obvious that A leads to a contradiction. And so, yeah, I can do an indirect proof within. And again, you could always do any proof with indirect proof. So if you really wanted to give you could actually have just started with assuming this, the negation of this as well, which then you'd want to use the first equiv method as a negation of a conjunction. But anyway, let's do one or two more since we still have time. Let's just do number 6. A implies B, B implies C, not A implies not C, not A. It is the case that not A and not C implies F. By the way, there's not going to be a translation on this exam. I'm just doing this because it helps me copy the proof right. Both A and C imply D. From all of that, it's supposed to follow that D or F. All right. Well, that looks fun. So I look at my conclusion. Does it occur anywhere in its entirety as a premise? No, which means you have to build it using Constructive Dilemma because there's two pieces there. Interestingly enough, people, if you just quickly glance at that, you might think you could do an EMI, say A and C, or not A and not C. That's actually not an EMI. And so we probably, yes, we could do some sort of constructive dilemma because one thing you might have noticed as you're writing it down, we don't need B anywhere else in the proof. So before I make any assumptions, I'll just go A hooks B, A hooks C, and that's 1 and 2 hypothetical syllogism, just to make that stupid B drop out. And so I now have if A then C, and if not A then not C. And I'm trying to get F or D. Does that help? It doesn't seem to. And so if you still can't see how to build a pretty easy constructive dilemma, it's just time to go to one of the shortcut rules. So remember, the first one we looked at, you could just say this is the equivalent of not B hooks F, and then assume not D, and work towards F. The other option, you could just negate this whole thing because not B or F is the equivalent of not B and not F. And so that just gives you more information. That's why I like to do it that way. So let's, now you could actually make this is the assumption or this is the assumption and then do the other parts at the end. Let's do it that way. We haven't done them like that yet. So not B and not F. This is an assumption. Nope, sorry, that's, I went not B or F. Yeah, we'll just do it that way. Assumption for indirect proof. gives me not D and not F. By line 7 De Morgan's, simp, com, simp. Oops, that should be 8. 8. Yeah, I don't know why I'm doing proof in pen. It seems like a bad idea, but oh well. Okay, and so again, I'm just going to use my little check mark method to note the ones I've already broken down. I've also, in essence, used those up in making this. So, well, I could do, can I break down line 3? Nope, not yet. Can I break down line 4? Yes, I can. I could do a modus tollens line 4 using line 11. And that gives me not both. Let's see. Well, that's ugly. Now you can do the De Morgans now, and you could actually do the De Morgans in a few different ways. Or you could maybe just wait and see if you need to do something with that later. Notice I like to do the De Morgans the other way. It makes one less step. If you go negation in, you end up with not A or not C. You have to do 2 double negations. If you go the negations out, that is if you go De Morgan right to left, then you just take one out of each. And that's a little more desirable in terms of number of steps. Okay, so I've broken that down. I guess I have to break down line 5 now. I'm going to do the same thing, which is modus tollens. Again, I hope you realize one of the reasons I'm going through this kind of without explaining each step is because the strategy is definitional. Once we're committed to indirect proof, we just break everything down until we get a contradiction. And so breaking down lines 4 and 5, the only way to break down horseshoes is modus ponens or modus tollens. So I do the one I can do. Gives me not A and C. Which gives me not A or not C. Okay, and I've broken that down. Notice I still haven't gotten an A or a C by itself. And so we can look at this in a few ways. But one thing we might notice is that we haven't done anything to premise 3 yet. Premise 3 is the equivalent of not A or not C using line 3 material implication. Now, why is that useful? Because don't forget your EMI. Not A or not A. That's a perfectly fine EMI. And then I can do a constructive dilemma with lines 18, 16, and 17. Allows me to conclude second or second, not C or not C. Except, dang it, I keep forgetting we don't have tautology in this textbook, but that is the equivalent to not C. And so what else might we do? Then we could do something similar with A or C. We could say, for instance, C implies not C, 19 implication. That's a And then we can, there's a couple ways we could do it now. But we still haven't really used line 3 very much. And so we might go to line 3 and go, well, C hooks A, which is transposition. And then why would I do that? Because here's another trick. This gives me not C or A, 21 impl. So if you haven't done this move before, you should have, because it was on some of the previous proofs. But we get not C or A and not C or not C, which is a conjunction of lines 22 and 19. And then not C or A and not C using 23 distribution. And that's equivalent to C hooks A and not C, 24 implication. So, I hope you realize at a certain point I'm just kind of spinning wheels intentionally, because we keep getting these weird things that we could put together and seem to look right, but then we don't get the contradiction out of it. And so remember, the other thing you can do, if you would like, is to, well, what would actually get us a contradiction here? C, right? So if I just assume C for an indirect proof, that gives me A and not C. By line 25, modus ponens. And then that gives me line not C and A, and not C. So I can indeed get not C. Now, why did I kind of stumble around with that a little bit? To point out that once you start getting these kind of premises together, and you're like, well, I know this can be not C, but our textbook doesn't allow it. And so that is, looks like my camera froze again. Dang it. Trying to make a point here. So on line 19, where I had not C or not C, how do I prove that? I could just assume C and then do a disjunctive syllogism to show not C, contradiction, or line 20, if I have C implies not C, I could assume C as an indirect proof to show et cetera, et cetera. And so if you're stuck in a way that, like, I can see how it gets out, but it doesn't fall out, it's an indirect proof you missed. So anyway, once we have not C, we can keep breaking down the premises. I really wish my camera hadn't frozen. I must have a time limit on this program. Seems to be what it is. So wherever the time stops, once you have C, sorry, not C, that lets you do a few things. One, you could get not B, which gives you not A with lines 1. So modus tollens line 2 gets you not B. Modus tollens line 1 gets you not A. Then you could conjoin them and get F, and there's your contradiction. So sorry, the camera froze when I was in the middle of trying to make a point here, but that's the general idea. So anyway, I guess since the camera's telling me we're done for the day, we're done for the day. Having said that, if this isn't enough practice for you, remember to use your discussion boards, use what you already have in the textbook, and then we also have the practice coming up with the recitation. So anyway, last point I was just to really emphasize, the reason I did that kind of 6-line digression is once you have one of these premises where like, I can see where I have to be able to get it, but I can't, just use an indirect proof because it'll just automatically fall out of there. Otherwise, we will see you at the recitation. Keep practicing.